So our objective is to convert a polar equation to an equation in target coordinates. Suppose I have two cosine theta. Too complicated for this class. So let's just do 2 cosine 2. The other one's going to be 5. And I want to convert this to the timing system. Sure, one might go with the same logic, x is equal to r cosine theta. Y is equal to r sine theta. Perfectly fine. But when you're going from polar to rectangular, I want you to keep this in mind. Sure, we know r is x is equal to r cosine theta. Divide by r on both sides. X over r cosine theta. Using the same logic with y over r sine theta. With respect to the right-handed triangle here, y is theta. Good. Let's see if you remember. What is that angle called? Great. What is great, but what is the name of that angle? Have the name. If someone likes your shoes, what would they give you? Okay, a compliment. So that's a compliment to Peter. Or they will give you money, depends. If that is theta, what is the length of that side hypotenuse based on what we wrote? Length. Based on what we wrote here, what is the length here? What letter is it? That's one. Oh, what is the length there? What is the length there? Thank you. So, I'm going to have this here now. It helps. So, where do we go from here? This is where identities come into play. Somehow I want to get rid of it or do something with it. But prior to doing that, I am going to write cosine theta in terms of sine and cosine. You can simply write it in terms of cosine. You pick. Do you want to write cosine theta in terms of sine and cosine, or do you simply want to write it in terms of cosine or sine? One of you can. That's not a question. I'm just asking for a choice. Do you want to write cosine to theta both in terms of cosine and sine, or just in terms of cosine, or just in terms of sine? Just cosine. Okay. Look at your notes. And find a way to write cosine theta just in time in terms of cosine. From a while ago, cosine 2 theta is simply 2 cosine squared theta. Yes. Well, I'm going to keep the 2 as is. 2 there as is. I can rewrite cosine squared theta as cosine, as cosine theta n squared minus 1. Good. What makes so far? Now I have 2 times, going back to what I wrote earlier, x over r is cosine theta. So I am going to replace cosine theta divided by x over r. It's okay. Square that minus 1. So I would end up having 2x squared divided by r squared. 2 times x squared divided by r squared minus 1. How do we combine those two? 2x squared divided by r squared minus 1. How do we combine this? Common denominator. We have to multiply and divide by the common denominator, which in that case is going to be r squared. So don't forget the r on the left hand side. So r equals 2 times 2 x squared divided by r squared minus r squared divided by r squared. Do I have a common denominator now? Yes. Which would mean I'll combine the numerators. 2x squared minus r squared divided by r squared. Left hand side. R. Good. Going back to the triangle, I recommended at the very beginning of the section that drawing this triangle and having it written down is helpful. At least until you get good amount of practice. What is the length of the hypotenuse is the opposite, and its adjacent sides are y and x respectively. What is the length of r? You don't have to make me proud, make the average proud. Thank you. Square root of x squared. That's y squared. Now I know how you really feel about it. Square root of x squared plus y squared. So r is square root of x squared plus y squared. I'm going to replace r by x squared plus y squared. If r is the square root of x squared plus y squared, what is r squared? Just x squared plus y squared, so minus good. Divided by what is the denominator? That is also x squared. Good. Like wow, you can use this. Yeah. It's just it's nothing special. So r squared becomes x squared minus y squared because r is square root of x squared plus y squared. So 2 square root of x squared plus y squared, 2x squared minus x squared is x squared. Distribute the minus in, you have minus y squared over x squared plus y squared. Good. Okay, so over there, I have square root of x squared plus y squared equals 2 times the numerator, which is 2 times x squared minus y squared, denominator y plus y squared. I'm going to multiply by x squared plus y squared on both sides, so that I don't have that denominator. Left-hand side, x squared plus y squared times square root of x squared plus y squared. Right-hand side, I simply have 2 times x squared minus y squared. Of course, the denominator is going to go away because I multiply by square root of x squared plus y squared on both sides. Good. This is current equation, right? Yes, no, maybe. Sorry. Yeah. How do we combine? Well, these two terms are identical. Do we agree? Yes. How do we combine these two? This is x squared plus y squared, square root of x squared plus y squared. I want to combine them and write it as a single expression. And exponents, properties of exponents. Carter?
About turning it into power 1.
Or it's not going to be 1/2, but when you combine them, what do you get? 3/2. So is that just 3/2, or is it a
Sorry. The power of 3
power? Power of 3/2 to what?
to the x squared plus y squared.
X squared plus y squared raised 3/2. I converted the radical to an exponent, combined the powers because it's product. So 2 times x squared minus y squared. I don't want negativity, positive person. So keep 2x squared on that side, move negative 2y squared to the left hand side. So 2y squared plus x squared plus y squared raised 3/2. That is my equation. So all I did is I distributed 2 here, 2x squared minus 2y squared. I move to negative 2y squared from the right hand side to the left. It became positive 2y squared. If I asked you to solve for y, do you think that is going to be an easy task or a challenging one? If I asked you to solve for y, is it going to be an easy task or a challenging one? Peter? I can't hear you. It'll be difficult. Why? Well, what do you think? Got an experiment going on here. And no matter how hard you try, why would end up depending on y itself. So in reality, you're not solving period. So that equation, even though that is a rectangular coordinate system, is going to present difficulty in terms of, say, manipulations, or even, let's take a simple step. Graph. In order to graph something using software, or using a calculator, for instance, we need to have y equals an expression in terms of x. In other words, y as a function of x. Good. No matter how hard you try, there is no way you could write that equation as y only in terms of x. I will bet my life. If you can't do it, okay, we'll find a way. Save that for later. But I know for certain, I will bet my life. There is no way you can write this expression and solve for y and write it purely in terms of x. In the sense, I have to have y on this side equals an expression purely on x. Not feasible. If that is not feasible, then graphing that not easy. However, if I went back to that, that is something you can graph easily in for the coordinates. Do you agree? First good. Now do you see another reason as to why sometimes dealing with the rectangular system could get painful? Okay. This is going to be a relatively easy. Now you're more to the take. You were wondering now, can't you start speaking. Okay, moving on. So two, this is going to be a relatively easier problem. Cosine theta, we know is equal to x divided by r. Sine theta is y divided by. Again, until you get good amount of fractions, equals. And do they have a common denominator? Yeah. Good. You can write that in terms of x and y. Oh, that's our objective. We want to get rid of r and theta. We express it in terms of x and y. I have successfully gotten rid of theta. I just want to find a way to rewrite r. Going back to the time, one root of x, y, and y is y. Good. That may not be the answer that my lab or the exam would or could have. Multiplied by the radical both sides. So you have 2 times square root of x squared plus y squared. equals x plus y. Yes. Square on both sides. 2 becomes 4. Square root of x squared plus y squared. If you square it, but root will go away. Square on this side. X plus y squared. Good. Going slightly over from student. I picked this problem because it's relatively easily done. That is a correct answer. So is that. So is that. But the Helmholtz system might want it quite simplified. So, right hand side, 4x squared plus 4y squared. Yes. Left hand side, sorry, left hand side, right hand side. But then left, right, it's automatic. X plus y squared is x squared plus y squared plus 2 times xy. All I did is 4 x plus y squared. Move everything from the left hand side, from the right hand side to the left hand side. 4x squared plus 4y squared minus x squared minus y squared minus 2xy equals 0. Good. Which would result in 4x squared minus x squared, 3x squared, 4y squared minus y squared, 3y squared minus 2x squared equals 0. There is a very good chance, I would say more than a 90% chance, that would be the answer that you would see on an exam. That would be the expression that you would encounter in calculus 1 or 2 or 3. So you should know how to go from here to there, which simply requires algebra. Good. Multiplied by square root of x squared plus y squared on both sides. Foiled, moved everything to one side, ended up getting that answer. Yes, even my lab probably is not going to be happy. That's if you have questions, talk to me. If not, as of today, you should be able to complete 6.1. Great. I will start that is 6.6 on Wednesday.